warm welcome to all the viewers. In today's session of Tourism and Hospitality Research, I will be discussing with you the eighth step of configurational analysis, that is, fuzzy set qualitative comparative analysis. This step, known as predictive validity testing, is quite important to justify your results and present them in your paper or your thesis. It is seen that most of the papers in FSQCA do lack upon two steps, which are the first step, which is contrarian case analysis, on which I had prepared the first video on FSQCA. You might like to go back and check the playlist to learn about how to do contrarian case analysis. And the last step, which is predictive validity testing. So when you are doing FSQCA, it is quite important to keep in mind that both of these steps are quite important. So let us go ahead and understand how this predictive validity testing is done. I will be using two softwares over here, that is spss and FSQCA. So you need to watch carefully all the steps to understand how you can do this. Let us start. Testing our solutions or models for predictive validity is important. Predictive validity shows how well the model predicts the dependent variable in additional samples. Here is the reference for this, which you might like to quote in your papers. The procedure is to divide the original sample into subsample and holdout sample. So the original sample which you have, after the calibration is done, so we take that CSV file into SPSS and then we divide it randomly by selecting 50% of the total cases and giving 0 to the cases which are not selected and coding 1 as the selected cases. Now there will be a new variable created in your data set. You name the first, that is labeled with 1, as subsample, and you name the one which is labeled as 0 as holdout sample. So this is the preliminary step. Next, what you need to do, you first need to compare the results from the original sample with the subsample results. That is, compare the consistency and the coverage which you got in from the truth table analysis of the original sample with the consistency and coverage of the subsample. Next step is compare the results from the holdout sample with the subsample results by selecting the configuration which has the highest consistency in the subsample intermediate solution results, and then building in that configuration and plotting that configuration on an XY plot where Y is the outcome and X is that configuration. How to do that? I'll show you in a while. Predictive validity is said to be established if most of the cases lie above the diagonal on XY plot, where X depicts the predictor's configuration and Y depicts the outcome. So now I'll show you the practical. Here we are in our FSQCA, and you saw that on the original sample, which is 204 cases, there are 204 cases in this data set. I conducted the truth table analysis as I showed you in the previous video. You might like to go back and check on that video if you want. Here the solution coverage was 0.593 and the solution consistency was 0.755. I have noted it down over here, you see in the Excel. Solution coverage 0.593, solution consistency 0.755. Now what I need to do? First, I'll go to File, Save As, CSV desktop. So once I've saved it on my desktop, I need to import that dataset into SPSS. Here I have imported that dataset in SPSS. The dataset which I exported out of FSQCA, which had calibrated values. So these are the calibrated values and adjusted values with the addition of constant 0.001, as I showed you in my previous videos, wherein FQ stands for food quality, CA is cultural authenticity, SQ is service quality, VM is value for money. These four are the predictors for the outcome, which is behavioral intention. A stands for addition of that constant, C stands for calibration. So after calibration, we added that constant 0.001 so that we don't miss out on those cases which are there at 0.5 intermediate level. So I've spoken about and discussed all those steps in previous videos, which you might like to go and check back. Now, the first step in SPSS is breaking down our data set into two sample sets. One is the subsample and other is the holdout sample. How to do that? I'll go to data, select cases, random sample of cases, sample approximately 50%. So the whole data set of 204 will be approximately divided into 102 and 102. So I click on continue and press OK. So now you have this new variable created. The name of that variable is filter underscore dollar. This is the name. I can rename it as new if I want for my easy understanding. I go to the variable view and rename it as new. So I renamed it as new. So you see here new. One is the code for those cases which are selected. You see here 1 and 2 are selected. That's why they are coded as 1 1 by SPSS automatically. 3 is not selected randomly and therefore it is coded as 0 by SPSS. Now, those cases which are labeled as 1, I'll call them subsample, and those which are coded as 0, I'll call them holdout sample. So what to do next? I again go to data, select cases, and I go to if condition is satisfied. If I take here new variable which was formed, new is equal to 1. If new is equal to 1, then continue. Copy selected cases to a new data set, which is subsample, right? Okay. And if again I go to data, select cases, if new is equal to 0, press continue. Then I call it holdout sample, right? Holdout and press OK. So now you see I have subsample, I have holdout sample data sheet created, and this is my original data sheet. Data set 1 is the original. Then you have subsample. You see here subsample. And then I have a holdout sample, right? Now, what I need to do, I need to export this subsample data sheet in a CSV format so that I can go into FSQCA and analyze the results, the truth table analysis of this subsample. Save as. Here I select .csv and name it subsample, right? And save it on the desktop. So I saved it. And now I go to FSQCA and I open this file, open, and I select that subsample file, subsample.csv here, open. So I got that file, you see. And now again, I conduct the truth table analysis, analyze truth table algorithm. ACBI is the outcome. ACFQ, ACCA, ACSQ, ACVM are the predictors. I click on OK. And then I go to edit, delete and code. Now, if you remember, in the initial video when I conducted in the truth table analysis for the entire sample of 204 cases, I used the frequency of 3, which is recommended in a paper by Papas and Woodside 2021. But here, as the sample size is half, so we can take it to be 2, and the consistency, which is minimum 0.75, I take it over here and press OK. Now I go to standard analysis, press OK, and I get the truth table analysis of the subsample. You see here, this is the truth table analysis of the subsample. I copy this and paste it on Excel. You see here, subsample results, frequency cutoff is 2, consistency cutoff is 0.76, and now I compare with the original. So this was the original and this one is the subsample. Solution coverage in case of original was 0.59. In subsample, it's 0.52. Solution consistency in original was 0.75. Here it is 0.78. So we can say they are close by. Not exactly the same, but yes, they are close by. So now we can go to the second criteria of assessing the predictive validity, wherein we will plot the highest configuration which we got with the highest consistency in the subsample, which seems to be this one, negation of ACFQ and presence of ACSQ and presence of ACVM, right? The highest consistency among all three configurations, the first is 0.79, second is 0.83, third is 0.84. So I select this configuration and I have to build in this configuration and then do the XY plotting, where X is the predictors, this configuration is the predictor, and Y is the outcome ACBI. How to do that? Let us again go back to SPSS, and now this time I'll go to the holdout sample. So this is the holdout sample. What I need to do? In the holdout sample, I need to create this configuration, which is negation of ACFQ. Now, what is negation of ACFQ? Negation of ACFQ means this is 1 minus ACFQ value, right? Those cases which are not present in ACFQ. So what will I do? I go to transform, compute variable. I say negative of ACFQ, right? NACFQ. And here I write 1 minus ACFQ like this. And the target variable's name is NACFQ, right? Click OK. So you got NACFQ. There's a new variable created, which is a negation of ACFQ as it was present in the configuration which we got in from the subsample with the highest consistency score. Now what next? Now, to get a single value for this configuration, the rule says, as mentioned in Ragin's 2008 book, that we have to take the minimum value out of these three. The minimum value which exists in any of these three conditions, that is the value for this configuration. How to get that? In SPSS, I go to transform, compute variable, minimum value out of that configuration. I go to statistical, minimum. So minimum out of negation of ACFQ, whether this is minimum, or ACSQ and ACVM. ACSQ, comma, ACVM, like this. So this will give me the minimum value out of these three, whichever is minimum that I will get in this column, which is labeled as minimum. I click on OK and I get this minimum. Now the step is easy. I go to graph, legacy dialogues, scatter dot, simple scatter, define, and on the y-axis I have my outcome, that is ACBI, and on the x-axis I have the minimum value of that configuration which was selected. I put it on x-axis and click on OK. So this is the graph which I got. I just double click on this and I get this line, which is the diagonal. Now you see here, as most of the points are lying above this diagonal, so I can say that most of the cases are a part of the outcome, are representing my outcome, which is behavioral intention. And this was the configuration which was selected from the subsample having the highest consistency value, and plotted that configuration with the whole route sample to get this graph. So you can copy this and put this in your paper and interpret it as third. So this is the way you do predictive validity assessment for FSQCA. I hope the video was quite informative and useful for you, and you will definitely share it with your friends and faculty colleagues. In the next video, I'll show you, in case you have two outcome variables, how to combine them in one, as FSQCA allows you to put just one outcome variable for getting the truth table analysis. So in that case, how you can combine two outcomes into one and then do the analysis. Thanks for watching and keep watching for more.